Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be the electromagnetic spectrum, and this topic requires some foundation in the waves chapter. If you are unsure, you can check them out in the top right corner. That is the previous video. So what are electromagnetic waves? They exhibit quite a couple of similar properties. Electromagnetic waves come in the form of all of these. These are some of the examples that we will cover in this topic. You need to know a little bit about them, then their uses, and they all exhibit some pretty similar properties, like they're all transverse. They are not longitudinal. When you see the word and it's got to do with sound, sonar, ultrasound, they're all longitudinal. They're all sounds. They are not part of transverse waves, so it's pretty easy to differentiate. They have oscillating electric and magnetic fields, no charges. They all travel in vacuum at this speed, 3 times 10 to the power 8 meter per second, and they follow this formula, V equals F lambda, another formula. So same, if you have been following this channel for a while, you know that in physics you need to do your extraction and then this is a formula, go and throw it. It's a very simple maneuver. Okay, and transverse waves, they do reflect and refract. And these are, I believe, two new vocabulary, which we'll cover more in the light chapter. And light, coincidentally, is also a part of the electromagnetic spectrum. So they move through different medium with different densities and they'll behave a little bit differently. However, the frequency always stays the same. So recap, what is frequency? Frequency is the amount of complete wavelength produced in 1 second. It's always the same. So when traveling through a different medium, perhaps the wavelength will change, longer to shorter or shorter to longer, but the frequency stays the same. So similarly, electromagnetic waves transfer energy. So like the battle ropes in the gym, energy travels from the hand to the wall. It's a form of transverse wave, and it's the same for all of these electromagnetic waves in the spectrum, and some of which are ionizing. So what does that mean? So it means that it has higher frequency with more energy. When it comes to contact with a particular material, it's able to push out electrons from the material, causing an ion to be formed. And this can cause harm to the target material. So for example, you want to sterilize certain tools using ultraviolet light. They can ionize it, cause damage to the bacteria that is on the surface and make it sterile, in the end killing the bacteria. So this is how it works. And lastly, all material, they do emit waves, electromagnetic waves. Hotter materials emit higher frequency ones. And now let's take a short look at the examples of the electromagnetic spectrum. We start with the largest one to the smallest one. Largest one in terms of wavelength, okay, it's going to be radio wave. Of course, it is used for radio, right? For communication, it needs to travel far. That's why the wavelengths are large. One wavelength is about the size of a football field, around there. So what I like to do is to remember the sequence. So what I will remember is RM, I, V, U, X, G. I don't have a good mnemonic for that. You can go and think about one to link them all up in one sequence. And secondly, what I need you to pay attention is from the largest to the smallest, the wavelength gets shorter and shorter and shorter. Look at the radio waves, it's like 10 to the power of 2, 10 to the power of 3, to the power of 4. It can be really, really big. For the microwaves, 10 to the power of negative 2, negative 3, infrared 10 to the power of negative 4. You can see that the wavelength is getting smaller and smaller. Then for visible light, 10 to the power of negative 6, negative 7, around there. Ultraviolet wavelength is 10 to the power of negative 8, X-ray 10 to the power of negative 10. And that's a fun way to remember because X is a Roman numeral for 10. So 10 to the power of negative 10 stands for X-ray. Alright, then gamma ray is the smallest one, 10 to the power of negative 12. So you can see it gets really, really, really small. Do note that all of them travel the same speed. So if the wavelength is large, and due to the formula of V equals F lambda, you have the same V, velocity, then your F has to change as well. Because of large wavelength, your frequency is going to be small in order to have a constant V, right? Simple mathematics. So from radio waves, you have big wavelength, your frequency is small. Then it gets frequency gets larger and larger and larger. You can see 10 to the power of 8, 10 to the power of 10, 10 to the power of 12, 10 to the power of 14, 16, 18, and finally 20. Okay, the third thing that I would like you to take note is the order of the light. Light comes in usually these 7 colors you learn in the rainbow. ROI GBIV. I believe in the previous couple of videos, I think in the reducing sugar chapter in biology, biomolecules, I think, the mnemonic to remember all the colors of the rainbow, ROI GBIV, is like Roy gives birth in Vietnam, right? Then the red will match with the red one. So once the color next to infrared will of course be red, and the color next to violet, ultraviolet, will of course be violet. So it's easy to match. So the red wavelength is larger than the violet wavelength. Alright, so it's pretty straightforward. There's a lot of patterns, a lot of fun patterns to learn. That's the fun part. The not fun part is the users. If you are struggling with it, you're normal, okay? So it's pretty much just memory work. Like radio waves is for your radio, your TV. They need to travel long distances. Astronomy, RFID, radio frequency identification tag. So literally the R will match with the R radio. Okay, next, microwave, of course, is your oven, microwave oven. How it works by heating up your food is because it will send these waves, and these waves will jiggle the molecules in your food, especially water, and this jiggling will create a lot of friction and therefore heat up the food. This is how it works. It's like running a comb through your finger. Against your finger, you can feel the vibration. This is exactly how it works over there. Infrared, remote control, alarms and imaging. Visible light, of course, for anything that has to do with vision, photography, optical fibers. Optical fibers work, we'll cover more in the light chapter, through internal reflection. It sends light signals through wires, and there's a lot of transparent material within the fiber. Ultraviolet, sunbeds. Sunbeds are for tanning, incredibly harmful, causes a lot of aging. Authentication of banknotes, disinfecting, not just water, disinfecting medical tools as well, scientific materials, equipment. X-rays, of course, for medical use. Imaging. Gamma rays, detection and treatment of cancers is a common use. Okay, so harmful effects of electromagnetic waves. Like mentioned earlier, some of these waves can cause ionization. They come to you, they come into contact with you, they are strong enough to push electrons out of the atoms, and that creates an ion unnecessarily. Thankfully, most of such damages can be fixed by our own cellular programming and immunology, our immunity cells, cell repair mechanisms, a lot of enzymes to help fix a lot of things. Or if damages are gone too far off, cells can undergo apoptosis, means programmed cell death. They will kill themselves in order not to become a harmful cell. There are also cells that can hunt and destroy damaged cells. Okay, but too much of it for the body to take, for all these repair mechanisms to handle, that's where it becomes a problem. So mutations can happen, and really bad ones can happen. I don't want to turn this into a biology class. It can turn into cancer. So do watch out for your exposure to sources like excessive UV, X-ray or gamma radiation. Stay safe. Okay, next one will be heating. So very simply put, you put your food in the microwave oven, that's an electromagnetic wave, it heats up your food. So that's a very direct understanding of a danger it can pose if you are receiving too much and too fast of it. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!